Welcome to Arise online classes. Today the chapter I am going to start with is sequence and series. So it is an often asked question, what is the difference between a sequence and a series? Okay, first of all, what is a sequence? It is a set of numbers forming some pattern. Okay, so for example, like 1, 11, 21, 31, 41, this forms a certain pattern, right? This is one sequence. Another one, 1 by 2, 2 by 3, 3 by 4, 4 by 5 and so on. Something following that is following a predictable pattern. That is a sequence. There are different sequences which we are going to be discussing today, but what is a series now? The series is the sum of these sequences that forms a series. Okay? Now, their sum is a series. Now, from what you have to study, some important sequences, the first of these is an AP or the arithmetic progression. Okay, so it is what is an arithmetic progression? It is a sequence of numbers in which one same term is added to the previous term to get the next one. Okay, it is, say, suppose I start with some number a, the next term would be a plus d. I am adding d to this to get the next one. The term after that, add d again to get a plus 2d, add d after that to get a plus 3d, a plus 4d and so on. You are adding that constant term d to get the term after this. So, the first term here is a, second term is a minus 1d, third term is a plus 2d, fourth term is a plus 3d. So, what would the general term be? It would be a n will be a plus n minus 1 into d. Just observe, third term has a 2d, fourth term has a 3d, nth term would have a plus n minus 1 into d. Okay, so what is d? A here is called the first term, d is called the common difference. Why is it called a common difference? That is common, that is, it's a common term which is the difference of consecutive terms. If I subtract this and this, don't I have d? Subtract this and this, I have d. So, I will tell you this with the help of an example. So, if it is, I will take a simple one, 1, 3, 5, 7, 9, 11, 13. Okay? What am I doing? I am keeping on adding that common term 2 to get the term after that. So, here the common difference is 2 and what is a? First term is 1. Now, if I want to get the common difference, it is actually, if I subtract any two numbers, I would get the common difference, any two. 13 minus 11 is 2. 9 minus 7 is also 2, which is the common difference. So, and if I want to find the 100th term here, what would be this according to this formula? It is a plus n minus 1 into 100, which is 100n minus 99. This is the 100th term. Okay. Now, in this itself, what is the general term? So, a n is a plus, that is 1 plus n minus 1 into d, which is 2n minus 1. 2n minus 1 is the general nth term of this particular AP. So, what would be the 100th term? 2 into 100 minus 1. Okay. Now, the general term of an AP will be of the form a n plus b, where a and b are numbers, positive or negative. Yes. Now, see, don't you observe that in this particular sequence also it is of the form 2n minus 1. So, it is of the form an plus b itself. What was the common ratio of this particular sequence? Wasn't it 2? Don't you observe that that 2 is a coefficient of n here? So, what can you conclude? The general term of an AP is of the form an plus b, and the common difference will be the coefficient of n, that is common difference will always be equal to a, as in this case. So, let me tell you, suppose you have an AP whose nth term is 7 minus 4n. You are asked to find the common ratio. What do you do generally? You can write the first term, second term, third term or whatever and subtract to second minus first terms to actually get the common difference. But by the property that I gave you just now, an easier way would be, what would be the common difference? The coefficient of n. In this case, d is minus 4. Is that clear? Now, again I told you a plus d, a plus 2d, a plus 3d, a plus 4d and so on. You have such terms. I told you, if I subtract consecutive terms, what do you get? The common difference. Now, if I subtract the third minus the first, what do I get? Don't I get 2 times the common difference? 2 times the common difference. Now, fourth minus first, 3 times the common difference. So, in general, if I subtract 100th minus 90th term, what would I get? I would get 10 times the common difference. Is it clear? Now, another easy, interesting observation in an AP. Suppose I have this AP, I will take this itself for convenience sake, 1, 5, 7, 9, 11, 13. Okay, I am just taking this AP which consists of 7 terms. What is the sum of the extremes? What is it? Isn't it 14? What is the sum of these two? Isn't that also 14? Sum of these two is also 14. Now, since this AP has an odd number of terms, there is going to be a middle term which has no pair. So, how can I predict that middle term? It is sum of the extremes divided by 2. So, what is the property that we have? Sum of the extremes is equal to sum of the terms equidistant from the beginning and the end. So, this, and if, as in this case, there is an unpaired term, what will it be? It is sum of the extremes divided by 2. Let's see how that will be useful to do a problem here. Suppose between 5 and 50. Okay, you are inserting 12 or 10 terms so that it forms an AP. Okay, so you are inserting A1, A2, etc., A10, so that this forms an AP. What is the sum of all these terms? I am going to use this property here. You don't actually, you can use the formula and do it, but you don't need it. What is the sum of these two? Isn't it 55? So, sum of these two will also be 55. Sum of these two will also be 55. So, how many such 55s will be there? In these 10 inserted terms, there will be 5 pairs. So, within these will be 5 into 55 and this 55 which is the sum of the extremes. So, what is your answer? 55 into 6. Just by logic, you can conclude that this is your answer without using any formula. Now, let me tell you one more. sum to n terms of an AP. The formula is n by 2 into 2a plus n minus 1 into d. So, using this very same question, 1, 3, 5, 7, 9 and so on, what is the sum to n terms? It is n by 2 into 2a, which is 2, plus n minus 1 into d, that is 2. So, this is n by 2 into 2 plus 2n minus 2, so that is just 2n. That is n squared. It is not a great example to have taken, because actually if you look at an AP, okay, the sum to n terms will always be of the form a n squared plus b n. Sum to n terms of an AP will be a quadratic in n without the constant term. It is of the form a n squared plus b n. Now, how do you, given this a n squared, this is actually is of the form a n squared plus b n, where a is 1 and b is 0. Okay. In this case, a cannot be 0, b can be 0 if you observe this particular example. Now, how do you find, given a n squared plus b n, how do you find the common difference? The direct method would be find sum to 1 terms, find sum to 2 terms. Okay. Subtract, see, you have an AP. Sum to 1 term is the first term, sum to 2 terms is the sum of these two. If I subtract these two, don't I have the second term? So, I have the first term, which is sum to 1 term, I have the second term, which we get by subtracting. If I subtract the second and the first terms, I would get the common difference. That is one direct way of doing this problem. But you can actually bypass all the steps if I tell you one small shortcut. Okay. So, it is always the common difference will be 2a. 2 into a, which obviously from here itself, what is a? 1. 2 into 1 is the common difference of this AP. Is that clear? So, nth term is a n plus b, common difference is a. Sum to n terms of the is of the form a n squared plus b n, common difference is 2a. Now, let me do a few questions. The third term of an AP is 7 and the seventh term exceeds 3 times, seventh term exceeds 3 times the third term. 3 times the third term by 2. Find the sum of the first 30 terms, or before that, find the 30th term. Find the 30th term. So, this is what A7, A3 is what? A plus 2D, that is 7. What is this? It is A7, which is A plus 6D minus 3 into A3, that is 21, that is 2. So, this is A plus 6D is 23. Here you have A plus 2D is 7. You subtract 4D is what? 16. D is 4. So, if you know D and if you know A, what would A be? A would be minus 1. You can find A30. What is it? It is A plus n minus 1, that is 29, A plus 29, A plus 29 into D. Substitute the values of A and D and then you get the answer. Now, I had told you before, what is the sum to n terms of an AP? It is n by 2 into 2a plus n minus 1 into d. So, Let us do 1. In this AP, 3, 7, 11, 15 and so on. Find the sum to 50 terms. I am not going to do the entire thing, I am just going to guide you. N by 2, 50 by 2 into 2A, 2 into 3, 6 plus 49D. So, what is D? D here is 4. And evaluate this, that is your answer. Now, the next one. Okay. So, now if A, B, C are in AP, I told you the common differences are going to be the same. So, you would have B minus A is C minus B. So, 2B is A plus C. This is an important observation. If you have three terms in an AP, twice the middle term would be sum of the two extremes. Okay, so, let us make use of this property to do a simple problem here. Find K if 2K plus 1, 2K minus 1 and 3K plus 4 are in AP. If these are 3 terms in AP, by what I told you, twice the middle term is sum of the extremes, 2K plus 1 plus 3K plus 4. So, you have 4K minus 2 is 5K plus 5. So, K is equal to minus 7, that is the value of K. Okay. Now, if you have 3 numbers in AP, and suppose their sum is given, it would be convenient if I take the 3 numbers as A minus D, A and A plus D. So, basically, suppose I am given 3 numbers in AP and if I am given that their sum is say 21. So, 3 numbers in AP can be written in this form, A minus D, A and A plus D. So, I would have their sum is 21. What is their sum? Isn't it 3A? That is 21, making A as 7. So, 3 numbers being given, their sum being given, what will be the middlemost? It will be the sum divided by 3. So, what are the 3 numbers now? 7 minus D, 7 and 7 plus D. Okay. Same way, if you are given 5 numbers and if their sum is given to me. So, how can I write the 5 numbers now? A minus 2D, A minus D, A plus D and A plus 2D, because you know what, in this AP, don't you realize that you are keeping on adding this D to get the term after this. So, the 5 numbers can be written in this form, and if their sum is given to be say 50. So, what is their sum? It is 5A is 50, A is 10. So, what are the 5 numbers? 10 minus 2D, 10 minus D, 10, 10 plus D and 10 plus 2D. These are the 5 numbers. So, this is how you write the terms if 3 or 5 numbers are given. So, let me do one. Find 3 numbers in AP. Find 3 numbers in AP if their sum is 21 and product is 315. So, you can write the 3 numbers as A minus D, A and A plus D. Their sum is 3A. So, A is 7. So, what are the numbers? It is 7. It is 7 minus D, 7 and 7 plus D. Okay, they are the numbers. So, we have made use of this fact that their sum is 21. Now what is a product? What is it? 7 minus d into 7 into 7 plus d. Isn't that 315? So multiply these two, you have 49 minus d squared is 315 divided by 7, which is 45. So what is d squared? It is 4. D can be positive or negative, plus or minus 2. So what will the three numbers be? You can either, if it's plus 2, the three numbers in AP are 5, 7 or 9. If I take minus 2, it is 9, 7 or 5. Either way, it is these three numbers in AP. Now, I told you how to take the numbers if there are 3 or if there are 5. What if there are 4? How can I write the numbers? Can I write them as a minus 3d, a minus d, a plus d and a plus 3d? Am I not adding 2d to each to get the term after this? Instead of adding d, I am adding 2d. It's the same common difference. But here, whichever way you evaluate and you get the value of d, remember that d is not the common difference of the sequence. What is the common difference? It is 2d. Okay, let me do one question. Divide 22 into 4 parts such that product of extremes is to product of means is 5:14 is to product of means is 5:14. What do you ask? 22 has to be divided into 4 parts. Okay, so and they form an AP. Suppose these are the 4 terms which I am going to divide this as. Now, 22 is being divided, so isn't their sum equal to 22? What is their sum? It is 4a is 22. What is a? It is 22 by 4, 11 by 2. So, what are the 4 numbers? 11 by 2 minus 3d, 11 by 2 minus d, 11 by 2 plus d and 11 by 2 plus 3d. These are the 4 numbers. What is given? Product of the extremes. What is the product of these two? 121 by 4 minus 9d squared divided by product of the means, that is 121 by 4 minus d squared, that is 5 by 14. Is this clear? Now, I hope you can actually simplify. Simplification is simpler. Simplify and then find the value of d, and hence a is already known. You can find the 4 terms. Now, if A1, A2, etc., AN are in AP, prove that 1 by A1, A2 plus 1 by A2, A3 plus 1 by AN minus 1 AN is n minus 1 divided by A1 AN. N minus 1 divided by A1 AN. Now, what is it that you observe about all the terms on the left hand side? A1, A2, first term, A2, A3. Don't you realize that they are all the product of 2 numbers whose difference is the common difference of that AP? So, what I do is, I introduce that common difference d. So, I would have 1 by d into d divided by A1, A2 plus d divided by A2, A3 plus etc. plus d divided by AN minus 1 AN. Now, in each of these terms, I am going to rewrite d differently. This d is A2 minus A1. divided by A1, A2. This D is A3 minus A2 divided by A2, A3 plus etc. This D is AN minus AN minus 1 divided by AN minus 1 AN. Now, separate these terms. 1 by D into this by this is 1 by A1 minus 1 by A2 plus 1 by A2 minus 1 by A3 plus etc. plus 1 by AN minus 1 minus 1 by AN. Okay? If you observe, you realize that these are terms that are going to cancel. You are going to be left with just the first and the last terms. What is it? It is 1 by D into 1 by A1, this is 1 by D into 1 by A1 minus 1 by AN. That is 1 by D into AN minus A1 divided by A1 AN. Compare with your question. A1 AN we are not going to touch. These are two terms which are not there. Let us write that down. What is AN? AN is A1 plus N minus 1 into D. Doesn't that make D equal to AN minus A1 divided by N minus 1? So, AN minus A1 by N by, sorry, is N minus 1 what do I need? I need N okay. AN minus A1 is equal to N minus 1 into D. Here you have AN minus A1 divided by D. Isn't that N minus 1? These many terms are N minus 1. N minus 1 divided by A1 AN, which is your required right hand side. Now, another property. Suppose I have A1, A2, A3, etc. are in AP. Then I add the same terms to each, they would also be in AP. Subtract the same terms, they also would be in AP. So, I would have A1 plus or minus K, A2 plus or minus K, A3 plus or minus K, they also will continue to be in AP. Same way, I multiply the same terms to each, they will continue to be in AP. So, you have A1K, A2K, A3K also in AP. Similarly, A1 by K, A2 by K also are in AP. Another thing, A1, A2, A3 are in AP, B1, B2, B3 are also in AP, then A1 plus or minus B1, A2 plus or minus B2, A3 plus or minus B3 will also be in AP. Two APs can be added to get an or subtracted to get a new resulting AP. But this will not hold for multiplication or division. If you find the product of these two, they will not be in AP. Now, let us make use of that to do a few problems. If A, B, C are in AP, the first you have to prove B plus C minus A plus C minus B, A plus B minus C are in AP. This is what you have to prove. Now, look at this, B plus C, A plus B and all that. Suppose, what is that term that, so that you would get this. If A, B, C are in AP, multiply throughout by minus 2, don't I have minus 2A, minus 2B, minus 2C are also in AP? Okay, to get a term like this, I have minus 2A. I have to add an a to get a term like minus a. Now what I do is I add a plus b plus c. What would I have? A plus b plus c minus 2a. What is that? B plus c minus a. A plus b plus c minus 2b. A plus c minus b and a plus b minus c are also in AP. This is the way you have to prove this result. Another one. Prove that 1 by BC, 1 by AC and 1 by AB are in AP. Now, A, B, C are in AP. This is more straightforward. If I divide throughout by A, B, C, what would I get? Don't I have 1 by, divide by, so A, B, C, divide by A, B, C. What would I have? 1 by B, C, 1 by C, A and 1 by A, B are also in AP. Now, another one. Same way, if A, B, C are in AP, prove that A into B plus C divided by B C. Then B into C plus A divided by AC. C into A plus B divided by AB are also in AP. So, you have A, B, C are in AP now. Like the previous question, you need a 1 by BC and also what do? I divide throughout by ABC. What would I have? 1 by BC, 1 by AC and 1 by AB are in AP also. Okay. Now, I add AB plus BC plus CA. What would I have? AB plus BC plus CA divided by BC, AB plus BC plus CA divided by AC and AB plus BC plus CA divided by AB are also in AP. Now, if I subtract one in which they continue to be in AP, I would have my required result. Now, the last of these topics in AP is the arithmetic mean. Now, if I have two numbers, say x and y, their arithmetic mean is x plus y by 2. Their arithmetic mean is x plus y by 2. Okay, so extended it further, if I have a1, a2, etc. an, what would their arithmetic mean be? a1 plus a2 plus etc. plus an divided by n. This is the arithmetic mean of n numbers. So, let us do a few. Okay. Suppose I have x and y, say 10 and 20. Insert one term in between so that this forms an AP. So, suppose I insert x, 10 x 20 would be an AP. So, since this is an AP, 2b is a plus c, so 2x is 10 plus 20 which is 30, x is 15. So, you would have what is the number to be inserted? Its arithmetic mean. Now, suppose you have to insert two terms for it to be an AP. So, I would have 10xy 20 are an AP. In this AP, isn't 20 the fourth term and 10 the first term? So, what do you have? A4 is 10 plus n minus 1, that is 3 times d. So, what is d? It is 10 by 3. Okay. So, what are the three terms to be inserted? 10 plus 10 by 3 and 10 plus 2 into 10 by 3 which is 20 by 3. These are the two terms. This is 40 by 3 and 50 by 3. If you observe, this 10 is just 30 by 3 and this is 60 by 3. So, these are the two terms to be inserted. Now, find n if a raised to n plus b raised to n divided by a raised to n plus 1 plus b raised to n plus 1 is the arithmetic mean of a and b. What is the arithmetic mean of a and b? Isn't it a plus b by 2? By 2? So, if you need a 2 here, I mean there are actually straightforward ways of doing it, but then for entrance you do not need that. If there needs to be a 2 here, logic says that if each of these is 1, then you would get this answer. When would this be 1? A raised to 0. So, that means n minus 1 should be 0, n equal to 1. Do not jump and write the answer, but before seeing whether n equal to 1 satisfies the entire term. N equal to 1 you will have a raised to 1 plus b raised to 1 by a raised to 0 plus b raised to 0, which is a plus b by 2. So, n equal to 1 is your required answer. Just one more question before we wrap up this lecture on AP. Between 1 and 31. M numbers have been inserted so that the resultant sequence is in AP. So, A1, A2, etc. AM. These are the M numbers inserted so that you have an AP and the ratio of the 7th to the M plus 1th. Ratio of the 7th to the M minus 1th terms inserted is 5:9. Find the value of M. Okay. Now, look at this. The first term inserted is the second term of the AP. Second term inserted is the third term of the AP and so on. So, 7th term inserted, isn't that the 8th term of the AP? Divided by what? The M minus 1th term inserted is the mth term of the AP. That is 5/9. What is the 8th term inserted? It is a plus 7d. So, it is 1 plus 7d divided by 1 plus m minus 1 into d is 5/9. So, you have 9 plus 63d is equal to 5 plus 5md minus 5d. So, you would have 5md is 4 plus 63d, this is 4 plus 63d plus 5d. This is 1. Now, that is not all. In this AP, do not you have 31 as the m plus 2th term? So, m plus 2th term is 31. What is the m plus 2th term? A plus m plus 2 minus 1, that is m plus 1 into d is 31. So, you have md plus d is 30. So, what is md? It is 30 minus d. Substitute that value of md here. What would you have? This is actually 4 plus 68d. Okay. So, 5 times md, which is 30 minus d, is equal to 4 plus 68d. This is 150 minus 5d is 4 plus 68d. So, you have 146 is 73d, making d as 2. So, you keep on adding 2 to get these m terms, and what is the value of m? You can substitute in one of these equations to get m into 2, that is 2m is 30 minus d, making 30 minus 2. 2m is 30 minus 2, that is 28, m is 14. So, I hope this topic on AP is thorough to you. I will come back with the next topic on GP later.